You're using the pen.
Okay, so let's talk about how to solve these problems. Any ideas?
Yes.
Okay, give me one.
You gave us a trick that you multiply the numerator and the opposite denominator.
No, good try.
Straight across.
Straight across. Good job. Did that line remind you?
Yes.
That's what Bronson said.
I was going to say it anyways.
You were going to say it anyway. So when you multiply fractions, you multiply straight across. So the answer to this would be 3/8. Okay? What about the answer to this one?
4/15.
Okay, finish these, and then I'll have table groups help me answer them. All right, so table 1, what's the answer to this problem?
Which one? Oh, wait. 1/10.
1/10. I accidentally wrote 2/10 this morning when I did it.
too. Right now.
Okay, so table 2,
3/10.
table 3,
9/20.
table 4,
8/15.
and table 1.
15/24.
Okay, and I was hoping we were going to have to simplify some of these, but it's not the case. Okay, let's look at the next one. So this is the application problem. I'll read it, then we'll talk about what to do, okay? Okay, Mrs. Golden wants to cover her 6.5 foot by 4 foot bulletin board with silver paper that comes in 1 foot squares. How many squares does Mrs. Golden need to cover her bulletin board? Will there be any fractional pieces of silver paper left over? Explain why or why not. Draw a sketch to show your thinking. All right, it says to draw a sketch, so I think we should start with drawing what would be the bulletin board. So something kind of like that. Okay, and it says her 6.5 foot by 4 foot bulletin board. Okay, so I'm going to put the 4 on this side, and I think I'm going to draw a little line here. This can be my half, and I'm going to write it as a fraction, and this is my 6. Now it says to sketch it out, so that means we're going to sketch out what those squares, what those 1 foot squares would look like. Okay, what's the actual problem that I'm solving?
6 times
6.5 times
4.
4. And to do this, we have to do 6 times 4 and a half times 4. Okay, so from this line you drew to the end, we're going to need 6 columns. So divide it in half, then draw 2 lines on each side of the half. And that should give you 6. And then to do 4, divide it in half, and then draw 1 line on each side. Now this is showing a half, even though it's not perfect. Can you tell it's a little smaller? I'm writing a half in there just to show. And each of these would be 1 whole square. And I'm not going to put all my ones on there. But you have the idea of how you would sketch this out? Okay, so go ahead and get that drawn. And then we're going to figure out how many total squares she's going to need. So what's the first thing you would do when you're trying to figure out how many she needs to buy? Wendy?
You multiply the numbers.
Okay, so you would do 4 times 6?
Yeah.
So that's 24. Okay. What's the second thing you would do? Aaron?
Oh, you add all the halves together.
You could, or you could think of it like this. A half plus a half is a whole, and a half plus a half is a whole. And we can actually solve this mentally, can't we?
Yeah.
So how many total squares does she need?
26.
26.
26 and a half. Oh.
I think it's just 26 square feet. Right? Because a half plus a half is a whole. All right. So she's going to have to buy 26 of those. Is she going to have any left over?
No.
No. unless she can't cut it directly in half, and then she might waste some. So when she buys 26, she has to make sure she doesn't mess up, okay? But that's how you would solve that one. Now, we know how to do it numerically. We know that we would multiply our whole numbers and then multiply our whole number times a fraction. So we're going to do 6 times 4 and a half times 4. You don't have to write this. And that would give us 24 plus 4 halves, which is what number? 2. And that gives us 26, okay? And that's what we've been doing the last couple days. All right? So starting today, we're adding another fraction in there. So instead of a whole number times a mixed number, we're going to have a mixed number times a mixed number. So we'll have 2 whole numbers and 2 fractions. Go ahead and tear this paper apart so that you can see the problem set and the chart at the same time. Okay? And on this one, I'm going to pull sticks so that one of you or a couple of you could come up here and figure out how to cover this rectangle with the tiles that I've provided. Then I'm going to teach you 2 ways to solve this problem. And I'm going to pause it while we figure out how many tiles we need. So thanks for your help in tiling that rectangle, okay? Okay, so we've got how many across the top here?
4.5.
So 4.5 units. Okay, you don't have to write that. There's nowhere for you to write it. And then how many going down?
2.5.
2.5 units, and I'm just going to write it with a U. Okay? So that's my multiplication problem. 4.5 units times 2.5 units. And I've got to get a total. Okay? Now, the thing is, we could eyeball this and we could figure it out. Or we could solve it and then come back and write the answer. What do you want to do?
Come back, write the answer.
I agree. Okay? So Aaron thinks he might know how big that little square is, but there's no way to prove it unless we just solve the problem. Okay? So, anybody have a guess? Besides Aaron, don't say it. Okay, whisper it to each other and see if you guys all have the same guess. Okay? Real quick. You can whisper it right there. So what's your guess?
1/4.
1/4. You're pretty good at fractions. Okay, so we're going to solve it to see if you're right. So go to the problem set, okay? We're going to solve this 2 different ways. The first way we're going to solve it is with the area model. Because I know, was this 4.5 times 2.5?
Yes.
Okay. Because I know that that's the way some of you prefer. Okay? So, did you notice that this is a little different? We've got 2 fractions we've got to multiply together. So we would need several sets of parentheses if we were going to do it that way, and we're not. Okay? So the first thing I want you to do is draw a rectangle that's big enough for you to write inside of. And then you're going to divide it into 4 boxes or pieces. Okay? So on top, 4 separated from a half. And on the side is 2 separated from a half. So if your rectangle isn't big enough, make it a little bigger. All right, so 2 times 4 is what?
8.
2 times a half. 2 copies of a half.
1.
Right. If you multiply 2 times 1, it's 2 halves, which equals 1. A half times 4.
2.
Be more specific.
4 halves.
4 halves, which equals 2 whole. And a half times a half.
A 4.
Let's see if you're right. So how do I solve this one? Just tell me. Straight multiply straight across, okay? So I've got Now, to solve it, all you have to do is add all the whole numbers and add up the extra fractions. So I've got 8 plus 1 plus 2. What's that?
11.
And
A fourth.
a fourth. Okay, so make sure yours looks like. All right, now I had a little boy in block 1 who really prefers to solve these numerically without drawings, okay? And I know I have some of you in here. So that needs to be an option. So right now I'm going to show you the best way to do that, okay? So I would take this problem, 4.5 times 2.5, I'm going to rewrite it. And instead of writing mixed numbers, I'm going to change them to improper fractions. So how will I change 4.5 to an improper fraction? I gave you a little visual the other day. You remember this little visual? So I'm going to take 4 times 2 plus 1. So that's going to be 9 halves. Okay? Write it down where I am. And then it's area, so we're going to multiply. 2 times 2 is what?
4.
Plus 1 more.
5.
5. Now, somebody in block, I think it was block 2 said, okay, so the answer is 14 halves.
45.
And what mistake did they make?
They added.
They added, okay? And that's easy to do. You know, the hardest part of fractions is remembering what strategy to use. It's not actually doing the work, because the work is easy, okay? So Aaron thinks it's 45. And what's the denominator there?
4.
4. Okay? Now, I'm going to show you one way to do this. You could do it in your head. Okay? You could know that 4 times 11 would be 44. Okay? But I want to show you another way in case you ever need it and because it's so cool. All right? So write down 45 divided by 4 using long division. Okay? And we're going to solve this, and then I'm going to remind you of something I showed you before. So write it down. So how many times does 4 go into 4? 1. And 1 times 4 equals?
4.
And if I subtract, I've
0.
got, can I bring down my 5?
Yes.
Okay. How many times does 4 go into 5? Once. So 4 times 1, and I've got a remainder of, now this has been a while, but I told you before, you can take your remainder, put it on top of your divisor, and you can make a mixed number. So what was the answer we got before? 11 and a fourth? And what's this answer?
11 and a fourth.
Okay, so if you choose to solve it numerically, you can always use this strategy. Quentin asked if it always works. And the answer is yes. It always works. Sometimes we choose to make it decimal quotients instead of mixed number quotients. But it always works. Okay, so let's go back to the chart. And what was our answer?
11 and 1/4.
And what's the label? Square units. Very good. All right. So now let's go on to the next one. You want me to pull sticks?
Yes.
Okay. And then we'll cover it and we'll talk about it later. Okay, that was a nice job. Good job, girls. Okay, so first thing I need to do is figure out what my problem is going to be. So across, how many do I have? 1 3/4 units. So write that one down. And then I've got going down, what do I have?
3 3/4.
3 3/4. And we can take a guess as to what this one is. How big do you think that is?
I'm going to say 3/8.
3/8? Okay. It's just a guess, isn't it? So would it be better to just solve the problem and then we'll know what it is? Somebody said they thought it was like a quarter of that. But if I pull it up, it's more than a quarter. I just can't tell if it's more than a half. Can you tell if it's more than a half?
And
I can't either. So let's take a look at solving this problem. So tell me the problem. 1 3/4.
1 3/4 by 3 3/4.
Okay. So we're going to start by using the area model. And both of these are options. You don't have to do both. It's whatever works best for you. We'll probably get to the point where we just use numbers. So the area model needs to be big enough you can write in it. And you're going to separate your fractions from your whole numbers. So go ahead and get that set up first. Okay? So 3 times 1? 3 times 3/4? 9/4, which is,
Or 2 1/4.
okay, 2 1/4. And then I've got 3/4 times 1,
3/4.
right? And 3/4 times 3/4.
9/8. 9/16.
9/16, because we multiply straight across. So we're going to do 3 times 3 and 4 times 4. Okay? So now what can I add together? Well, I could totally add my whole numbers, couldn't I? 5. And can I add any fractions together? Do we have any common denominators?
3/4. Yeah.
So what's that?
12.
4/4 or 1 whole, right? And then what do we have left?
6.
9/16. So my answer is
6 and 9/16.
and 9/16. Okay? So all we have to do now is solve it numerically and see if we get the same thing. So let's take a look at it. What's 1 times 4
4.
plus 3?
3 or 7.
So I got 7/4 times, what's 3 times 4?
12.
Plus 3?
13. 14.
15 15/4. Okay? Now, it would be really nice if we could simplify this ahead of time, but it's not going to work out. Because 4 doesn't go into 15, and 4 doesn't go into 7. So we're just going to have to multiply it out. Okay? Anybody know what 7 times 15 is? Figure it out. Here's what I know. I know 15 times 2 is 30. So I could go 30, 60, 90, and that would be 6 times 15. So what is 7 times 15, Isaiah?
Oh, I got 105.
I agree.
Same.
And what is 4 times 4?
16.
Okay, now we know our answer is going to be 6 and something, right? 6 and 9/16. So I think we're going to try the long division way again, just so you can practice it, so it can be an option. So I want you to write 105 divided by 16. Now I know it's going to be a 6, and I know 16 doesn't go into 10, so I'm going to put a 6 up there. But if I didn't know it was a 6, I could probably figure that out. Because 7 times 15 is 105, so 7 times 16 would be too big, right? So down here, I'm going to do 16 times 6. Figure that out. What'd you get?
96.
96, okay. So 6 times 16 is 96. And when I subtract, I bet I'm going to get 9.
Yeah.
So there's regrouping there. What's 15 minus 6?
15 minus 6 is 9.
So I can take my remainder, put it on top of my divisor, and it can become a mixed number. Did I get the same answer twice?
Yes.
I love it. Okay, so let's go back to the lesson. What was our answer?
6.
And 9/16. Okay? Now, the next few, we're just going to solve Thank you. I forgot my label. Square units. Okay? The next few, we're just going to solve numerically. Okay? Without dragging it. Well, we can use the error model possibly. So this one is going to be, let me look at it. I think it's 3/4 times 1.5 maybe? Let me double check. 3/4 times 1.5. So C is going to be 3/4 units times 1.5 units. Now to do that, it's too hard to drag it over, but here's what I know. I feel like my answer is not going to get much bigger. What do you think? No, because I'm multiplying a number less than 1 times a number less than 1. So I'm going to go to my problem set, and let's draw the area model. Actually, we don't need it. 3/4 times 1.5. Yeah, let's put it on there. No, let's not. I can't make up my mind. Okay, let's put it on there. So 3/4 here, 1.5 here. Whoops. Okay. So what's 1 times 3/4?
3/4.
Okay. And what's 1/2 times 3/4? 3/8. So if I add those two together, I've got my answer. But when I add those two together, I've got to find a common denominator. So write this down. 3/4 plus 3/8. What's my common denominator?
4.
It better be 8. Okay, so write this down, please. So I've got 3/8 gets to stay the same. What about 4? 4 times what equals 8?
2.
So 3 times 2 equals 6. So what's 6 plus 3?
9.
So that's 9/8.
1 and 1/8.
1 and 1/8. Okay. So now I want to show you how to do that numerically. It's a little easier numerically. So I'm going to take 3/4 right here times 1 times 2.
2.
2 plus 1 more.
3.
So 3/2. And I'm going to multiply straight across. Bella, you might think this is easier this time. That's all there is to it. So sometimes it might be smarter not to draw the area model and just do the math. Okay? Especially if you don't have two whole numbers. Okay, rectangle D. Let's look at it. It's 3/4 times 1/2. So this one we'll solve numerically. Okay? So all I'm going to do is multiply. And if I multiply straight across,
3.
what do I get?
3.
And that's your answer. Clever, huh? I know. Okay, so that is all of the kinds of problems that you might see, all right? Let's go ahead and turn that problem set over and see if there's anything else we can solve on the back. I think this first one is pretty complicated. Is there more than one?
Yeah.
Oh, it's the same thing all the way. Okay, so let's figure it out. So it's a 3-step problem. We can totally do this. Okay? So right now, I'm going to read it. Colleen and Caroline each build a rectangle out of square tiles placed in 3 rows of 5. Okay? So here's what I've got. And I'm going to do it twice. So I've got 3 rows, right? And I've got 5 in each row. And if you're me and you're lucky, you can duplicate that and drag it over. I'm going to spread them out a little bit so I can do some math on the sides. Okay, so go ahead and get those drawn and then we'll continue. Okay, so now we're going to figure out the size of each one of these boxes or tiles. So Colleen used some small tiles. They were 1 2/3 by 1 2/3. So we got to figure out the answer to that problem. And we'll do it down here in a minute, okay? And Caroline used tiles that measured 3 1/3 by 3 1/3. So those are a little bigger, aren't they? Okay, go ahead and label. So it says, draw the girls' rectangles and label the lengths and widths of each. Okay, we got that? Yeah. Okay, so now it says, what are the areas of the rectangles in square centimeters? So are these centimeters? Yeah, they are. Oh, are they? Are they inches or feet or what are they?
Feet.
Centimeters. Okay, so that's a tiny tile. So the first problem is 1 2/3 times 1 2/3. Okay, now we can solve it with the area model, or we can solve it numerically. We can do both. So what's 1 times 3?
3.
Plus 2 more.
5.
So that'd be 5/3 times 5/3. So what's that?
25
25 ninths.
So how many times does 9 go into 25?
2.
2. And what's 2 times 9?
18.
18. So 25 minus 18?
6 9.
I think it's 7.
What? I didn't hear.
7.
25 minus 18. Is that 7?
Yeah, it's 7. Yeah.
Okay.
Next is
So here's what we know about Colleen's. Each one of these squares is 2 7/9. Jot that down. And then, is this Caroline here?
Yes.
3 1/3 times 3 1/3. So that's going to be 3 times 3 is 9. So what do we have here?
106.
100 ninths. Because 3 times 3 is 9. Okay? So how many times does 9 go into 100? I feel like it's 11. But let's do this. It's just going to be faster. Trust me. You trust me?
Yep.
Okay. So if I'm just looking at the 10 here, okay, I'm showing it with a highlighter for now. How many times does 9 go into 10? Once. So put my 9 there and subtract. Okay, bring down my 0. I was right, it's 11. 11 and what's that trick?
1.
Take your remainder, put it on top of your divisor. 1/9. So each one of these boxes is 11 1/9. Okay? Now we got to figure out the total area. Oh goodness. So how many boxes are in each?
15.
15. So we got to take 15 times 2 7/9. And 15 times 11 1/9. What's the easiest way to do this?
2. Oh.
Area model?
No.
Yeah.
I did.
Okay, I'm going to put it on the area model. We'll see. So here's 15. This is 2, and this is 7/9. So what's 15 times 2? 30. What's 7/9 times 15? We know 7 times 15.
It's 105.
105 ninths.
right? Haven't we seen that before?
Yeah.
Yeah, we have. Okay, so if I add that all up, what was this? 105 ninths?
Yeah.
Oh, I think it was 105 sixteenths, wasn't it?
Yes.
Okay, so let's just figure it out. So it's 11 and 6 ninths plus 30. What is it? 41
and 6 ninths.
6 ninths. Simplify that. What are you going to divide by? 3. So that gives me
2 ninths. Or
2/3. Okay? So square centimeters. So that's one of them. Okay? The other one, can we do it real quick? I know we're out of time, but we'll do it fast, okay? So 15 times 11. Anybody know what that is?
150.
55.
165. 165. Yeah.
165? You sure?
Yes.
15 times 1/9.
15.
15 ninths, which is 1 and 6 ninths. So we've got 166 and
2
2/3.
and 3.
Forgot my label. So Caroline has a much larger area, which we already knew, right? And it looks like we're going to have to skip the last one. Good job.